So let's assume that we could call up these patients and we could somehow find out what happened to these censored observations. And so we make some calls and we can get the real values for these patients. And we see that 2 of them are greater than 25. 1 of them is smaller than 25. We can now have our new estimate of our survival at 25, which includes this real information. And this is going to have the number of patients who survived to 25. And so that's going to be patient 2, 3, 5, and 6. So that's 4 patients out of 7 in total. And notice that our previous numbers that we had were 2/7 if we assume everyone died immediately, and 5/7 if we assumed that the censored observations never experienced the event. And the reality seems to be somewhere in between those numbers, where 2 out of the 3 patients survived beyond 25 and the one other didn't. And this is a problem that shows up all the time, and we unfortunately aren't always able to acquire the reality for the censored observations. So in that case, we face a very important question that we have to answer with survival models is, how do we estimate the probability of survival past some time t, here 25 months, when we have censored observations without actually making calls to find out what the real event time was? And this is what we'll look at next.